Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farah Izzati binti Adam, CE210052. I want to explain about finite impulse response and infinite impulse response. For finite impulse response, filter implementation is in MATLAB. We can design an FIR filter using the field function or other filter design methods like windowing, frequency sampling, and others. So this will give us the filter coefficients in MATLAB. Other than that, we can use the filter function in MATLAB. So we can do to applying the FIR filter to our input signal. So we also can provide the filter coefficients and the input signal to obtain the filter. Second, for the infinite impulse response, in filter implementation, similar to the finite impulse response, that we can use the filter function in MATLAB that apply the infinite impulse response to our input signal. So the MATLAB frequency function can be used to visualize the frequency response of the infinite impulse response filter as well. At Arduino implementation, we can use libraries like the signal processing library or the Arduino DSP library to implement finite and infinite filters on Arduino boards. So these libraries usually provide function to define the filter coefficient and perform filtering on the input signal. Next, by implementing the filters, we can use using MATLAB and Arduino IDE in our experiment with different filter designs, coefficients, and the input signal to observe the filter response and deepen our understanding of our behavior. We do research from Ahlia Ahmed Aliti and Amir Ardazirek. From their investigate, the Windows method in MATLAB software is commonly used for designing finite digital filters. That application using Blackman and Kaiser Windows. So the filters are crucial in signal processing for carrying digital information by modifying carrier characteristics such as phase, frequency, and amplitude. So the filter coefficient must be determined and adhere to guideline before plotting the frequency. Next, finite filters are commonly used due to the reliability and ability to produce output that closely resemble the original signal. And filters are often preferred for noise removal application, and it play a crucial role in reliably transferring original data in signal transmission. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Huda binti Muhammad Nazri. My method number CE210081, and I will explain about the problem statement and the objective of our project. For problem statement, the noise from electrical interference, environmental condition, transmission mistakes, and sensor imperfections can reduce signal's quality and make it difficult to extract information. The digital processing techniques can filter signals to reduce noise while maintaining critical elements. This project focuses on implementing digital filter simulators, selecting a microcontroller board, and converting discrete time signals into the exact domain for analysis and design. The objective of this project is to design a simulator of the filter systems and are urged to utilize a microcontroller board. Next, to create FIR and IRR filter that can be used to retrieve the transmitted signals, original signal, while filtering out undesired signals. Last, to use and research the Z transform of filter signals and the discrete Fourier transform in practical application. Next, the method that we use for implementing this project is, the first one is digital signal processing techniques, which is involve methods and algorithms used to process and modify digital signals in various applications, including telecommunications, audio and video processing, image processing, radar system, and medical imaging. Common DSP methods include discrete time convolution, sampling and quantization, discrete Fourier transform, digital filters, and Z transform. The next technique is the Z transform technique. Is a mathematical approach used in discrete time signals and system analysis and processing, investigating frequency content, stability, and system responsive of discrete time signals and systems. Next, for finite impulse response filter are used in audio and picture processing, communications, and control system. They generate the output signal by converging the input signal with a finite duration impulse response. FIR filters have advantages such as linear phase response, stability, and ease of implementation. However, they demand more computer resource than infinite impulse response IR filters. And lastly, for infinite impulse response filters provide infinite impulse response due to their feedback topology. They have a recursive computation of the output signal based on both current and previous input and output values, allowing for recursive calculation of the output signal. IR filters provide advantages such as efficient implementation, fewer coefficients, and are excellent for applications demanding sharp roll-off and accurate frequency control. However, they may display non-linear phase responses, which can change the timing of various frequency components. Overall, IR filters are an effective tool for digital signal processing due to their efficiency and versatility in frequency response design.
Assalamualaikum, my name is Muhammad Farhan bin Muhammad Yusof, CE210182. I will explain about the hardware implementation. The Arduino Uno and ACS712 current sensor module are used to measure current, connect the Arduino's 5V pin to the VCC pin, ensure an independent power source, and connect the ACS712 module's ground pin to the Arduino ground pin, and connect the pin to the N analog input for the accurate current measurement. For the digital signal processing technique, the Arduino implementation of discrete transfer function involves selecting a filter type and initializing its parameters. The filter object reads input signal using analog or digital input pins and continues filtering process the result by repeating step 4 through 6 in the loop. The chosen filter has unique properties and computation. For IIR simple low-pass filter, analog pin converts raw value to voltage, ensuring sensitivity of 0.815 and converting current value to the voltage using a digital low-pass. For the IIR digital signal, Arduino code adjusts cut-off frequency and computes coefficient using low-pass class instance. The instance uses second-order sampling frequency Fs and Boolean duration for loop function. The filtered signal Yn is filtered from the low-pass filter.
Bismillahirrahmanirrahim. Assalamualaikum and good evening. My name is Muhammad Syafiq bin Muhammad. Untuk hari ini kami akan buat task mana berkaitan dengan tajuk Digital Signal Processing System. So dekat sini dia beritahu as a system is important, you and your team are required to understand the filter concept strongly. Maksudnya kami perlu faham konsep filter. So kat sini pun dia beritahu FIR dan IR filter theory and concept. So dekat sini dia dah minta requirement dia, iaitu mana digital signal processing technique, and then filter system representation which uses Z transform technique. Okay, so group kami menggunakan software MATLAB dan Arduino. Dan untuk MATLAB adalah kami menggunakan untuk FIR, dan untuk Arduino adalah untuk dapatkan bacaan menggunakan hardware. So ini adalah coding yang mana untuk FIR. So kat sini kita dapat tengok filter dia, so coding dia, dan kat sini dia beritahu signal frekuensi F1 adalah 50 and then frekuensi F2 adalah 150. So kat sini kita dah beritahu, kat sini dah labelkan contohnya. Okay, untuk title original signal, and then X kita labelkan time, and then Y kita labelkan amplitude. So untuk yang dekat subplot 211 ni, so bila kita dah dah salin kat sini, so kita akan tunggu untuk run supaya kita akan dapat bezakan dua data yang berbeza. Okay, kita run dulu. Okay, so dia punya data pun dah keluar. So kita dapat tengok sini dia punya graf. Okay, ini atas ni adalah mana graf original, yang mana kat sini kita tengok terpindah amplitude dia, and then kat sini time dia. Tu yang membezakan yang tadi tu lah. And then filter rate signal. Okay, ini yang tadi kita bezakan ni lah. Yang dekat time dengan anytime ni dikira untuk graf asal tu lah, and then kita ada signal ni yang mana setelah run kita akan dapat sign yang baru. ok, yang ni lah saja tu say.
In this testing, the Arduino used a discrete transfer function to filter current sensor wave, resulting in a 10% remaining signal at 50 Hz. For the next testing, without adding the motor, it shows that the value 1 is the current value without filter, and the value 2 is the filtered in simple low-pass filter. The amplitude of raw signal is in the range of 150 and negative 150, while the filtered signal is between 0 and negative 50. In the third test, digital low-pass filter, after adding the motor, it shows that the current value is the current without, which is value 1 is the without current, and value 2 is the filtered with digital low-pass filter. The amplitude in the range of raw value is 300 and negative 100, while the filtered signal wave is between 100 and 150. This wave is delayed by 10 milliseconds. This shows that current signal increase after the load is connected. Digital filter, including FIR and IIR filters, are crucial in signal processing. The choice between these filters depends on the MATLAB and Arduino application, which is it will integrate development environment, enable direct inquiry and understanding, research and support their effectiveness in noise reduction and signal improvement. IIR filter utilize recursive filter types, understanding past values and variables from earlier measurement cycle. The study of digital filters provide practical knowledge, promote advanced signal processing system, and increase the data analysis of interpretation across various areas.
My name is Nik Ahmad Makimi bin Zulkifli, AE200008. So in conclusion, in this project we learn about digital filter in signal processing, which is the purpose is to extract relevant information and reduce noise. So the types that we learn is FIR filter, linear phase, stability, simple implementation is the reason why we use FIR filter. So for IIR filters, we know that this is efficient, precise frequency control, and rapid roll-off. So we have to choose the right filter. In order to choose the right filter, we have to consider phase response, memory limits, and frequency control. So FIR filter have the exact frequency control and adaptability and versatility, and IIR filter has resource efficient, fewer coefficients, and equivalent response. So implementation tools that we use is MATLAB and Arduino IDE. So MATLAB is the software and Arduino IDE is the hardware. So direct inquiry, filter design and signal processing approaches in this project. So for filter analysis, we learn about frequency range inspection, and for algorithms that transform, discrete Fourier transform are used. So the benefits is to reduce noise and enhance signal, customizable for specific application, and realistic simulation with Arduino. So the application of digital filter in signal processing is for telecommunications, audio or video processing, image processing, and medical imaging. That's all from our group. Thank you.